that's why I didn't have the chance to actually work with the finalized G2 value. But it's just a parameter that it will just shift the whole thing up or shift the whole thing down. That's it. So we did this. Okay. Yes, that's true. As I just said, that it will take everything either up or down. It wouldn't change them with respect to each other. So you're correct. That is gonna the problem with dark side 50, that it's not aligning with the dark side 50 trend, is not gonna be fixed by taking into account this G2 thing. But we took a different independent measurement as
Recording in progress.
Done from this. Okay, okay. The last comment, the germanium measurement is susceptible to some uncertainties. That is what I said in my thesis. And actually it's, yes, I understand that this is this kind of detector is meant to be used in this kind of work, but the detector that we did. So basically we were to peak from the calibration data. So since we are calibrating at MEVs, I don't know, like 200 MEV, and our signal is coming at 1 MEV, we are not trusting 100% with this, okay? And since also we don't want to trust much the theoretical understanding of us between the K42 and the Argon 37 correlation, because it's affected by a lot of things. Also, they're vulnerable to a lot of other things. The kind of geometry and the positioning of this, the source inside the thing affects a lot. And the fact that is in care of these things. So in order, since this is like the main idea that we wanted to find in the Argon 37, we didn't find it to document our trial, because we learned a lot from it, and we document this thing and go forward with our
if you have a signal and you want to correct it for draw quantitative conclusions, then of course you have to apply all this. But if you have no signal, then you have no signal.
Exactly. Yeah. So yeah. So thank you again for your comments. I hope I addressed your comments, and let me know
satisfied.
if okay, sure. Thank you. Okay, Professor Kazuki. Okay. So in the bottom equation in 1.38 cannot be in 137. So these are the equations that are mentioned. Yes, I agree with you, of course, that this sigma SD cannot be equal. Putting a different naming that this is the proton contribution and this is the neutron contribution, and actually how they actually go into the big thing is not a clear summation to this equation.
My point is that the third line.
This one, yeah.
Yeah. So here you have sigma SD on the right hand side.
Sigma SD on this?
No, on the right hand side.
This?
So the equal is the same. I mean the line equation. I mean, AN equals
written this. Yeah, I'm sorry. Okay, how we kind of separated it? Like, okay. This is a bit explained in a textbook, and I didn't want to go much. I mean, that makes sense. We actually did this kind of approximation. Is that they thought they said that we're gonna think of this spin-dependent sigma as two components, and how we're gonna consider them as two components by putting 1 to 0, and we're gonna deal with it later. Actually, this is what they did. So we're gonna put the AP equals 0, and we're gonna check the AN, and then we're gonna put AN into the next step. Yeah. Okay, so this is what was done in the textbook. Maybe I should have been clearer into putting it into my thesis.
Okay.
Yeah. Okay, so this equation should be written in this way instead of this way. Yeah, thank you for the suggestion. I understand that it's a bit sometimes not nice for the, I don't know, mathematicians or physicists, I'm not sure which one, but they don't like to see these things this way. But I'm sorry. Okay, it's but I think I'm mathematically referring to the same thing as long as I'm did this is what I mean to. So these comments on page 9, this should be this, and just without the bigger than, because like we don't have any proof that it's bigger than. We have a kind of approximation that it's within this range of the 10 to 17. We cannot say that it's bigger than 10 to 17. I guess that's the point, or no?
So this is bound on the dark matter lifetime, right? So you don't know. Are you claiming that dark matter should be decaying with lifetime 10 to the 17 second, or dark matter shouldn't decay?
No, should be decaying, but a really, really big T.
But why do you say dark matter must decay? It can be completely stable, right?
It can be completely stable?
Yeah.
Okay. I think in this part I was mentioning that one of the evidence coming from cosmology was saying that if it has a decay time, it has to be bigger than this.
Exactly.
Okay.
So it should be bigger than, not nearly equal to.
Yeah. Okay. I sorry, I just confused the two things. Yeah. It should be bigger than, not equal to. Yeah. The average, okay, in equation 1.19, the average should be taken on both the sigma and the V, not individually. Yes, that I should have stated it clearly that we are doing this approximation, that we are considering that sigma is independent, but I didn't say it out loud. let's say. In section 1.3, the spin independent and independent are not clearly defined. Yeah, these comments, thank you for catching, and yeah, I will actually correct them. Okay, comment 4. Yeah, about the CDM model and the sigma. I think I mentioned it. You can double check. The CDM model, I just used this as a naming. Maybe I should have said what the name, like I said, the lambda CDM as the name of the model, okay? Without going into why it's called lambda CDM. But maybe I could have just said that lambda is the dark energy contribution, and the CDM coming from the cold dark matter theory, okay? Okay, this equation is not clear. Okay, so what I was trying to explain that in this equation, if we put the mediator mass to be that of the mass of the electroweak gauge boson, we can get the GF that imposes the limit of Lee and Weinberg on the mass of the dark matter particle, or the WIMP. So what I was just saying by this simple, maybe it's not 100% accurate, but I thought it is, that the GF squared equal to G to bar 4 over M to bar 4. I'm not connecting the theories. I'm saying that if we consider, since we don't know what's the mediator with dark matter and we don't know anything. So let's say if we put M equal this number, we will get GF equal this number, which means that the M of dark matter should be this number. This is what I was trying to do.
Okay. Okay.
Is that okay?
Mm-hmm.
Okay.
I understand your intention, but
sorry?
I understand your intention.
Okay.
But in the thesis, it should be stated more clearly.
Clearly. Okay. Nice. Okay. The author claims that it is obtained by solving the 114, but this cannot be done without specifying phi r. There's an extra r here. It's not there. Or postulating some relation between phi r and rho r. That's correct. Yeah. It's. I gave the reference to the textbook where I took this part from. But like since this part of the derivation was in the event rate was actually done in textbooks, I didn't try to cover it because like this is one of the things that I try to do as a PhD student, that I wanted the next PhD students to have a better chance at surviving this than me. So if there's some information that we're missing in textbooks, I was trying to complement them by giving all the details of the steps. But if the textbook actually covered this part, I was like referring to the textbook, like you need to be a PhD student, you need to do some job, okay? Like I'm not gonna do everything for you. So I try to do this. So yes, there is actually like this is the discontinuity equation that relate the phi r to rho r, and you need to take into account the Jean's equation that simplifies the beta r to put it as 0. So you can simplify this to this and you can reach this. And actually this is the textbook that is used as a reference in this thing. It matter, like it goes through all these kind of derivations in details. So it's a good textbook that I used.
So equation 1.15 contains sigma v factor, right? So, but in equation 1.15, 14, it doesn't have sigma v. So I was wondering where sigma v factor appears. Maybe you...
The sigma, yeah. Okay.
Maybe you assume some function for phi of r.
Okay. So equation 114 for you is missing
So
the sigma V doesn't appear on equation 114. That's what you're saying?
Yes. So you say 1.15 is solution to 1.14. So where sigma V squared in 1.15 comes from?
Yeah, it's coming from like imposing the Jeans theorem on the discontinuity equation that relates the delta phi, the d phi, for with rho through these equations, the Jeans equations, that has a sigma in it. So this sigma, like maybe it's the what's it called? The naming of the sigma R and sigma V are different, but here the sigma R and sigma T, I think they have a different definitions than what the sigma V that I have to, but these both sigmas actually are contributing at the end to the sigma V.
Okay.
I understand this.
Okay. So yeah, because probably between equation 1.14 and 1.15, there is only one line. You say just solving this equation, you get that.
Yes. Okay.
But
I should have.
Probably this is not very accurate.
Sure. Okay.
Yeah.
So I should have said that solving this continuity equation, assuming some assumption, some relation between the phi R and rho R from this textbook, would have solved to this. Okay.
Okay.
I'm sorry. Okay. The KEN is in relativistic and the KEN out is not relativistic. Yes, that's correct. I was like trying to link stuff some here and there with the appendix. So in the appendix, I did all the analysis in relativistic formulation, and I did it in the lab frame. So I tried whenever it was possible, maybe I didn't do it in the best way, to kind of make sure that the equations that I use in my thesis and the equation in the appendix, you can go back and forth. Maybe I should have went through all the way from the appendix to reach the equation that I used there, as Professor Lukasz referred to. But yeah, this was the idea. There was no intention, let's say, other than this, to show this in relativistic thing and non-relativistic thing. Maybe I should have also put some comment on the approximation, but I think the approximation was taken at the very end, and it's a bit justifiable that we're dealing with non-relativistic particles, that we don't need to take the relativistic things.
But probably the both are indeed non-relativistic, right? Otherwise,
yeah, both are. Sorry.
Probably both energies are non-relativistic, and that's why even if you use relativistic expression for the initial energy, it is still okay. Is that correct? Because if indeed final energy is relativistic, and if you use non-relativistic expression, then the result will be false.
No. I'm saying that our dynamics is non-relativistic.
Okay.
So since it's non-relativistic, I did all the calculation in the relativistic way. Okay. Since it's easier.
Yeah. Okay.
Then I take the approximation at the very end.
Okay, that's fine. Okay.
Yeah, but definitely the dynamics, it's 14 MeV neutron, so I don't think it's that relativistic at all. Okay. Okay. That's it for Professor Kazuki. Did I answer all your things?
Yes.
Okay.
Yes,
Thank you
very much.
Okay, Professor Lukasz. Okay, there is no abbreviation list included in the thesis. I agree. Yeah, it could have been better. So, and the Z equal 1100 is the redshift that is like referring to the recombination time, but I didn't say it, and as you said, it's a well-recognized fact.
Okay, these minor comments are not so important.
Okay, so yeah, these things I thanks for suggesting, and also the CF thing, that was a miscalculation on my part, and I responded on this already. So yeah, it's a bit surprising that the goal of the dissertation is not clearly stated in neither abstract nor the introduction chapter. Yeah, the goal of the dissertation is quite technical, as you understood. So if I put it in the introduction, I think I will lose you. So what I try to do is put it in the abstract, but I'm not 100% sure that like the final version of the abstract is the one that you had at your hand. Maybe this is my mistake, that the abstract right now reads in the last paragraph. This is the last paragraph. So I clearly say what this dissertation is about. So I say the dissertation details the commissioning process of the detectors and outlining the data acquisition methods employed during the experimental campaign conducted in Catania. Furthermore, it presents the subsequent data analysis focusing on the measurement and the analyzation yield down to this energy range. And the study contributes to the understanding the LR, TBC, and the low energy range. So maybe it's not the same version, but this is my bad. I'm sorry.
Okay, it's in the conclusion, the most important.
Yeah, and in the conclusion as well. Yeah. Okay. This I responded to. Yes, you're correct. Acknowledge that I could have explicitly reached the recoil energy, as I said in the appendix, to be also in the center of mass frame that I use in the calculation. However, there's no however. Like I just since our measurement was done in the lab frame, I did all the calculation was done in the lab frame, and this is the one that I followed in the appendix. Okay, so this is the derivation and the equations that I used in my code. The equations in the text of the thesis are the center of mass frame, because this is what's familiar usually to people. When you talk about kinematics, you don't show the equation in the lab frame because it's a bit complicated. You show it in the center of mass frame, which is a bit less complicated.
Have you tried to estimate what difference would be if you use this simpler, because the center of mass is much simpler formula, yes? And
correct.
To what extent it approximates the evaluation of energy?
What do you mean, to what percent?
What is the difference in percent from between the center of mass and lab frame?
The result?
Yeah. Well, how does it affect if you approximate the lab frame? Because if you put the lab frame into the center of mass angle, yes, because what you have in your setup, in the geometry of your setup, what you know is the laboratory angle.
Yes.
Yeah. And
yes.
if you put this laboratory angle to the not proper formula, which is center of mass formula, how much you deviate your energy estimation? Yes, because this would the people which would use this center of mass energy formula and use the lab's angle would have some difference in the result. Yes.
So you're saying if I took the
answer, some
angle,
error, some systematical error, it would introduce some systematical error to the result. Yes.
Okay, so if I took the angle calculated in the lab frame and I used it in the equation meant to the center of mass frame, how much percentage is difference between this? I didn't do this. I'm not sure why I would do this. Because
people might use then using your PhD thesis, they might try to reproduce your result.
Okay,
and with a wrong formula.
Okay. Yeah. I agree.
They would get.
I think I should have made it clearer that I say in the thesis that this is the formula for the center of mass frame, and maybe also calculate, maybe also from the appendix reach the other like from the lab frame go directly to the center of mass equation, so we kind of connect these two ends. So this, if
my estimate is it's more or less the factor goes in 1 plus mass of neutron over mass of argon. So it's like 2.5%, 1 over 40 factor added there.
Yes, correct. Yeah.
So it's not much, I think, in this, because then you take the energy only to make some cuts, not for the analysis. So it does not contribute much to the result. Yes?
Yeah.
But this, I mean, the
Okay.
author should be
Okay.
aware of it.
Okay. Yeah. Thank you. Okay. Okay. Maybe this wasn't that clear, and how we reconstruct this thing. So we receive the raw waveform. This is the one in yellow. Then we filter it. This is a moving average filtered waveform. So it kind of moves with a window, takes the average, and then go back and put the average here. Then you get this filtered waveform line in the middle of the raw waveform. Then we do something called the MA residual. The MA residual is the moving average residual, which is we subtract the difference between the filtered waveform, which is in yellow, from the moving average window. Okay. When we subtract the moving average from the filtered waveform, we receive these things. Okay. This is not anymore a known quantity called an amplitude, because it's not amplitude technically. It's what we call prominence. Okay. Similar to the prominence concept in statistics, but it's not exactly the same. It's defined here as this way. So I'm defining it to be the difference between the filtered waveform and the moving average, and it's kind of a proxy to the amplitude of the signal. Okay, so it's not technically the amplitude; it's a proxy for the amplitude. And we're using this then to put the hits. So these hits are the ones that exceeded a certain threshold, and then we do this reconstruction of pulse. So we understood that if we have all these things all these hits next to each other, that this is one pulse, and this is another pulse, and this is another pulse that maybe you don't see here, okay? But it's actually there, but it's just for this thing is not visible in this range. That's it. Okay. Last thing, it would be valuable to have a comment on why integrating window width was chosen for microsecond. Okay, so this is the single photon electron time profile. So we did a kind of deconvolution of all the sebum signals. We kind of try to understand or model how a single photon electron time profile should look like. Okay, so we modeled it in this way, and this data coming from the laser calibration that we took in our in our detector, and we kind of estimated that the decay time that a proper signal takes for a single photon is way less than this thing. The 4 microsecond range is a bit less, not way less, but also, and it's not including much of the background noise and the fluctuations. So it's kind of an optimization that was done by trial and error and observation. That's it. So it's just to make sure that we are catching all the pulse, not part of the pulse, and we're taking the integral under part of the pulse. That's it.
Okay, thank you.
Okay, these are the minor comments. So yeah, I just listed them here. Thank you for the suggestion. There's one here that is about the effect of non-proportional response to absorbed radiation and is not addressed in the calibration of barium fluoride detector. However, it should have a negligible effect for the analysis of the data in the study. True, at this stage it wasn't, but it is currently under investigation, as I mentioned in the conclusion chapter, that we're still actually trying to understand more about the energy response of the barium fluoride and see if we can use it to enhance our event selection.
Yes, what would be your energy threshold for the, because you accept probably pulses, you cut off probably some low energy pulses, yes, from the barium fluoride. So where is your threshold usually for the detection? For the detection?
Okay. Okay. For the current study, I didn't apply any cut on the energy, on a threshold on the BAF energy. I applied only time constraints. So I require that the time of the BAF is in reasonable time with respect to the TBC, with respect to the plastic scintillator. I require some things on the geometry. Reconstructed properly.
Yeah, but you need to cut off noise somehow, yes? So yes. Where is this cut? So how high your noise is?
So when a barium fluoride trigger, kind of?
Yes.
It's the hardware trigger threshold that I think it was.
So you accept even like 10
kVs, yeah.
Linear, yes. Sorry, the response of barium fluoride.
I'm not sure I understand what you mean.
The amount of light emitted from the scintillator is not linear with the energy deposited.
Yes.
And yeah, but you are only triggering you're just catching whether there was a gamma to start your
the start of time of flight. Yeah.
Time of flight. So
yeah.
It doesn't.
So yeah, it's not affecting that much. I agree with you. Yeah. But still, yeah, this part also is still under investigation. So we are doing anyway, because this is required to publish something that full done study. So we are going through this thing. So yeah, that's all the comments. And yeah, let me know if I addressed your comments correctly.
Yes, thank you very much.
Thank you. Okay, again.
Okay, thank you very much. Yes, indeed. So thank you for detailed reviews and the answers. Now we have the last part of the audience can ask questions, make comments. Already see that the Zoom audience. Sure, I can go on.
Hello. I'm not having any questions really. I just want to tell Paul we're so proud of him today, and he did just a great job.
Thank you.
Okay. There is still some points to be covered. So, not too soon. Not too soon. Okay.
Okay. Anyone else?
Any other questions or comments?
I have one more. Not related to my previous.
All right. Okay.
Sure.
So one of your statements was that you used barium fluoride because there is a fast decay component from the scintillation, 0.8 nanoseconds, because you wanted to have a high throughput.
To have
the high throughput. I mean, to have possibility to acquire high count rate.
Yeah. Without dial-up. Yeah.
But plastic scintillators are also fast. I think that the reason for using barium fluoride is rather to have a very fine resolution.
Sure.
Not high counting rate. I mean, because there are much cheaper ways to get high count rate capability than barium fluoride scintillators.
I agree. Yeah. It's also for the energy resolution. Yeah.
For the timing resolution.
So for the timing resolution, yeah.
Mostly for the timing resolution.
Yeah.
And yes, but large plastics, would be also. I mean, they have short decay, yes, because this fast component is not the whole scintillation. There is the tail.
The decay. Yeah, sure.
Anyone else?
I don't know if it's someone in these chats or.
I don't see any raised hands on the audience. Okay, please.
So in your thesis, the story of dark matter starts with the
John Ort.
Yeah. Why? That's a non-standard.
Why what?
Why that? Because that's a non-standard way. His findings were based, or his hypothesis of dark matter was actually based on incorrect observations.
True.
So people
Yeah, yeah.
usually start from speaking, no?
I understand, yeah, but it's like I think in science, the first person that says that there is something wrong, look here, this is the first person, even if he didn't say what is wrong. Okay, so in science, understanding that there's something doesn't make sense is something, and it's a big thing. It's not something easy. I understand.
Okay,
this.
so you are aware of this fact,
Yeah, yeah,
and
yeah,
that was your conscious decision to present things this way.
Kind of, yeah.
Respect.
Yeah.
Okay. Well, if I do not see any other questions, then the Scientific Council will now go. Members will also we invite the reviewers. We will have a short summary discussion on the defense, on the dissertation. We'll make a vote on awarding the degree, and we will be back with the results soon. Okay. There is one more raised hand, but is there a question or just a congratulatory? All right. Okay. So the members of the Scientific Council, please.
My nephew is 10 years old.
All right. Okay. All right. I think we can restart our proceedings here. I'm very glad to announce that the Scientific Council awarded the degree of doctor to our candidate, Zakhary. There was little doubts about that. And well, in the comments, everybody present was impressed by your presentation and general sort of performance during the defense. Okay, so now we proceed to the presentation of the diploma, and the oath will be done by the supervisor.
Okay. So I'll read in Polish, and you'll have to then say the Polish. Szanowny doktorancie, stajesz dziś przed nami, by po przedstawieniu rozprawy i zdaniu, których wymagany poziom wiedzy i umiejętności, uzyskać stopień doktora nauk ścisłych i przyrodniczych w dyscyplinie naukowej astronomii. Przyrzeknij zatem, że wiedzę swą tu zdobytą wykorzystywać będziesz zawsze dla poznania prawdy, prawdę tę będziesz głosił i nią kierował się w życiu. Przyrzeknij także, że zawsze będziesz wytrwale pracował dla rozwoju nauki, a jej wyników będziesz używał nie dla niegodnych zysków i próżnej sławy, lecz dla dobra powszechnego. Przyrzeknij również, że swym zachowaniem nie splamisz godności, którą ci mamy nadać. Czy przyrzekasz?
I should say. Okay. No, you can say and I repeat. I cannot.
Przyrzekam uroczyście. Przyrzekam uroczyście.
Przyrzekam uroczyście. Czyże? Czyże. Uroczyście.
Wow! There was one more sentence. One more.
It's okay. It's okay. It's not a problem. It's okay. Just different culture.
Na mocy uchwały Rady Naukowej Centrum Astronomicznego imienia Mikołaja Kopernika Polskiej Akademii Nauk mianuje pana Zakhary doktorem i przyznaje panu wszelkie prawa i przywileje przysługujące doktorowi, na dowód czego wręczam panu ten dyplom.
Okay.
Okay.
Congratulations.
So much. Thank you so much.
ألف مبروك يا بول.
And members of the Scientific Council, please, like in 3 to 4 or maximum 5 minutes, gather again in the small room or the other Zoom. We still have a number of points to discuss. So we will be back in, I don't know, half an hour, 3/4 of an hour. Maybe there will be something waiting for us.
Champagne already.
But
also in the meeting, it can motivate you.
Okay. That sounds good. Okay, thank you.
Thank you.
Thank you, Bol.
Paul, congratulations. Dr. Paul.
دكتور مبروك. دي ماما طبعا كده عشان احس ان انا قاعده معاك يا بول. اكيد حاسس بوجود بتاعك.
Non ti collegavo insieme a Euro prima. E diciamo ciò che
Aspetta, lì Cicilla. Vedi che già sta facendo altro. Ciao Paolo, congratulazioni!
Ciao Paul!
Ciao!
Complimenti, bravo!
رفعت راسنا يا بولس.
صباح الفل يا اسطى.
برافو يا بولس، برافو يا حبيبي، برافو.
تسلمي لي يا امي.
Congratulations يا بولس.
ألف مبروك يا حبيبي.
congratulations يا
ألف
بولس.
مبروك.
Congratulations.
ألف مبروك يا بولس.
يعني
I'm so proud of you.
Polish part.
محدش بيعرف يزغرط عندكم أكيد. قمت لكم بالواجب أنا.
مبروك يا بولس.
The refreshments, some refreshments in the back. Okay. Huh? Yeah. Can I take a picture with the reviewers before they?
Congratulations يا بولس.
Niente voce.
He's my nephew. Okay. Okay. Can I take? Huh?
Congratulations.
Looks like.
Congratulations بولس. Congratulations دكتور بولس.
خلاص يا عم.
So, congratulations.
Congratulations.
Congrats.
Ciao Fiorella.
Ciao Fiore.
مبروك فيوريلا.
Hi, Bol. Congratulations.
Adesso. Ciao, buona giornata. Ciao.
You hear me? Yeah, thank you. Thank you. Thank you, Father.
I'm so proud of you.
Thanks, Yo-Yo.
I'm Daniel.
Huh?
I'm Daniel.
Dodo.
سلام يا أبي.
Sorry, that's Dodo.
صلواتك ودعواتك يا أبونا.
Thanks.
الكاميرا مش راضية تفتح معايا ليه يا سنة؟
Thank you. Okay, we are going into a different room. So احنا رايحين أوضة تانية فهنقفل الزوم هنا. Thank you all for attending and I'll see you soon. Okay? Thank you. Bye. Ciao, ciao.
ألف مبروك يا بولس.
Ciao.
ألف مبروك يا
Ciao. Have a
بولس.
nice
Bye,
day.
Paul. Congratulations. Bye, bye.
مبروك يا بولس. باي باي يا بولس. باي. باي يا بولس.
Ai, Bolis. Devi che sullo schermo. Qua.
Ciao, Paul. Salam alaikum. Okay.
Bye bye.
باي باي. باي باي. باي باي.